Hello, my dear students. Welcome to ninth standard online classes in our YouTube channel. In the last period, we have discussed the velocity time graph for uniformly accelerated motion, and we also studied the area under velocity time graph when the object is in uniform motion and uniformly accelerated motion gives the distance traveled. Hope you understood all those points. In today's lecture, we are going to learn about the velocity time graph for non-uniformly accelerated motion, or you may say non-uniform motion, the velocity time graph in that case. And also we are plotting some graphs in this session of the video lecture. Okay, let us understand the velocity time graph when the object is in non-uniform motion or non-uniformly accelerated motion. When the object is in such situation, the velocity time graph varies at different points. The velocity time graph varies at different points and hence it is of any shape. So, when the object starts moving randomly or say non-uniformly, so the velocity time graph varies accordingly and hence it is of any shape. So we have plotted velocity time graph for non-uniform motion. This is the first case and this is the second case. So you cannot get any slopes, you cannot get any areas in such situations. Hope you understood this part. Okay, dear students, let us summarize what we studied up to the distance time graph as well as velocity time graph. Okay, so the summary: when the object is at rest, the distance time graph will be a straight line parallel to x-axis. So when the object is at rest, the distance time graph is a straight line which is parallel to x-axis. Okay, when the object is at rest, there is no question of velocity time graph. Since the object is at rest, then there is no question of velocity. Okay, when the object is in uniformly accelerated motion, we are not bothering distance time graph right now. So we are only considering the velocity time graph. It is a straight line starting from origin, and the slope, if you draw, then that gives or that provides the acceleration, and the area enclosed under velocity time graph, that gives you the distance traveled by the object. Similarly, when the object is in uniformly decelerated motion, again we are not considering distance time graph. So what I have made, I am not adding these two because we did not plot the distance time graph. Okay, why it is so? The distance time graph will not give the complete information and hence we are skipping that portion. On the other hand, the velocity time graph provides the straight line falling from y-axis to x-axis, and again the slope gives you the deceleration this time, and area again gives you the displacement or the distance traveled. So when the object is in non-uniform motion or non-uniformly accelerated motion or non-uniformly decelerated motion, whatever you take, when the object is in such situation, the distance time graph as well as velocity time graph, it is of any shape. So velocity time graph is also of any shape. Distance time graph is also of any shape. I hope this summary will help you to understand distance time graph as well as velocity time graph. Okay, dear students, let us plot some graphs for velocity as well as distance time graphs. So the first point, that is construct the graph for given data using the table. So the data are mentioned in the table, so we are plotting the graph for such table. Remember, it's my suggestion that you should plot the graph or any graph whichever I am giving, so that should be in the graph sheet only. Okay, so let us try to draw the graph for the given data. So first you need to plot y-axis and x-axis, y-axis and x-axis. So this is the distance time graph. Therefore on y-axis we are having the distance, which is in meter, and here we are having time, which is in second. Keep always in mind while drawing the graphs, you should scale them properly. So let us take the scale for the graph. Scale x-axis first. X-axis is equal to, you may take 1 centimeter, which is equal to, here you can distribute equally because 0, 2, 4, 6, 8, and hence you may take each centimeter carries 2 seconds. So this is very much important in physics. You are already drawn many graphs in mathematics. Here we are applying that. Therefore x-axis in this case, which is of 1 centimeter, 1 centimeter will be our unit right now. So 1 centimeter equals to what? I am considering equally now. Every 1 centimeter has 2 seconds. Every 1 centimeter has 2 seconds. And similarly you can write it for y-axis too. Y-axis, since it is constant, you just go on rising 1 centimeter equal to 1 meter, like that. By that you can get the scale right. Okay, so x-axis of 1 centimeter provides 2 seconds, and y-axis of y-axis of 1 centimeter gives you 1 meter. Here we are considering. So we need to keep eye on these parts. In physics they are playing very much important role. Okay. These points are mandatory, and you may take these values in different manner too, in different manner as you are okay, as you are experiencing with these graphs, you will know how to adjust the x-axis and y-axis respectively. Okay, I am considering x-axis, so just this as 1 centimeter, oh sorry, we took 2, this as 4, this as 6, 8 and 10, and similarly this point is 0, that is the origin, 0 you may take. So here again 1 centimeter is equal to 1 meter we considered, similarly 2, similarly 3, 4, 5 and 6. These extra values definitely help us to plot the graph properly. Okay, let us take the first point. So we are having 0 on time axis or x-axis, so just go on finding. This will be the first point. For 0 we are having the distance of 5 meter. Similarly for 2, that is also of 5 meter. For 4 again it is 5, and hence it is appear to be a straight line parallel to x-axis or time axis you may take. So what is the indication of this graph? The indication of this graph is a straight line parallel to x-axis. Means the object already it is having some distance of 5 meter, and that 5 meter remain fixed for given instance of time. Hope you understood this part right. Let me take another example here. Construct the graph using the given table. So the distance is in meter: 0, 50, 100, 150, 200, 250. Similarly, time is in second. Again, it is 0, 10, 20, 30, 40, 50. So this is our the data. We are plotting the distance time graph for these values. So first you need to take the scale. So we are having this range 0 to 250, here 0 to 50. Therefore, better if you are taking x-axis, 1 cm is equal to 10 second. Okay, so 1 centimeter is equal to 10 second, and on the other hand 1 centimeter is equal to 50 meter. If you consider these two values, let us check how this graph goes. Okay, so this is zeroth line or origin, and this has to be our first centimeter in the graph, in fact that region. And on the other hand we have again 10, 20, 30, 40, 50, 60. You may take one extra. Again, as I said, that gives you in a comfort zone. And similarly, for y-axis we have 50, 100, 150, 200, 250, just to take 300. So we are having these values adjusted into the graph. Let us mark those values. So here the distance and time are 0, therefore first point lies on the origin itself, and second one will be 50 meter for 10 second. 50 meter for 10 second, it is probably somewhere here. So this is our point. And second, similarly for 100 we are having this point 20. Similarly for 150 that will be 30. So this is our point. Similarly for 200, so this is our point. If you use scale, then that will be better for you. So this is the rough drawing I am making at. So please make use of scales and measuring devices properly. So if you just connect these lines, so this gives you a simple straight line which is passing from the origin. This is the straight line passing from the origin. Again, you can calculate the slope and the area if you want. Okay, so slope can be, this is the object. You can conclude from this graph the object is in uniform motion. The distance time graph shows like this. So if you take the slope, that gives you the velocity probably, and you may take its area too if you want. This is how we are constructing the graph for given data. With some more videos and few more examples on graph, I will see you in the next period. Till then, take care of yourselves. Bye bye.